This is Algebra 2, Chapter 12, Section 1, Part B, in which we continue studying the trig functions in right triangles. Okay. Last time we talked about the 6 trig functions and how to use them to find side information in the right triangle. We can also use those same 6 ratios to find angle measurements. But in order to do that, we need to use what's called inverse trig functions. And if you look on your trusty calculator where you see your sign button, the shift sign or the second sign right up above the sign button, you'll see sign -1. Okay, that's what we're talking about, the inverse of sine. Okay, if sine of our angle is equal to x, some value or other, then the angle is the inverse sine of that x. Or if we're talking about cosine, then it'll be inverse cosine. Tangent will be inverse tangent. Inverse secant, inverse cosecant, and inverse cotangent all exist, but they're a hassle to use, so we tend to stick to just those 3, unless somebody's just being mean to us and making us use them. Which could happen, I guess, from time to time. So we're going to try to figure out the value of this angle x. All right. Just like we talked about last time, we need to know what information is out there. From this angle x, 15 is our opposite side. 17 is across from the right angle, so that's our hypotenuse side. Opposite and hypotenuse calls for sine. So sine of x is equal to opposite over hypotenuse, 15 over 17. Okay. I'm going to turn that into a decimal just so that it's easier for me to work with. Okay. Some of your calculators will be able to put it in as a fraction and it'll be okay. For some of you, it's going to work out better if you use a decimal. Your mileage may vary, it kind of depends on the calculator. But we can deal with that as we go. Now I'm going to do the inverse sine of that decimal I've got. And the inverse sine of that, my calculator tells me in degree mode, is 61.928 degrees. Okay. If you didn't get that answer, then check your mode. Make sure you're in degree mode. Again, like we talked about last time, I can help you figure out how to do that. I just need to know your calculator to do it, because each calculator does it differently. Let's try another one here. We have another angle x that we're trying to find. What information is out there? We have the side across from that, that's the opposite, and we have the side next to it. It's not the hypotenuse, because the hypotenuse is down here. So this must be adjacent. Well, opposite and adjacent is a job for tangent. Tangent equals opposite over adjacent. Again, I'm going to turn it into a decimal just to make it easier for me to work with. Now I'm ready to do the inverse tangent. And the inverse tangent of 1.5 is 56.310 degrees. Okay. Now, another idea we're going to have to look at is something called the angle of elevation and the angle of depression. When you look up at something, you look upward through what's called the angle of elevation. It's the angle you have to turn your head up to look up at something. If you're looking down at something, then what you're looking at is the angle of depression. Now, it's very important to understand when we're dealing with either one of these, elevation or depression, they are always measured from a horizontal line. Okay, you always measure them off of a horizontal. the biggest, most common mistake in problems like this is people will try to put, especially the angle of depression, off of a vertical line. It doesn't work that way. It's impossible. You can't do it. It always, always, always comes off of a horizontal line. Can't stress that enough. Always. Horizontal. Okay. So let's do a couple of these problems just to give you the flavor of it, give you a feel for what's going on. We have a ramp that we're going to use to unload a moving truck. And as I always do when we're moving, I like to measure the angle of elevation for the ramp. And I find out that that angle in this case is 32 degrees. Now the top of the ramp is 4 feet above ground level. The job we have is to calculate the length of the ramp. So I've got a picture that gives us the simple layout of it. Didn't draw the moving van and all that good stuff. But we have the 4 feet above the ground. We have the 32-degree angle. Notice I'm measuring it against a horizontal line. And then we're looking for the length of the ramp. The ramp sits here. So we're looking for that. Now from our angle, what do we have? We have opposite. We're looking for hypotenuse. Opposite over hypotenuse is sine. Okay. So sine of 32 equals 4 over x. We'll figure out sine of 32 degrees from our calculator, multiply by the x, and then divide by the decimal. And we find out that the ramp is a little over 7.5 feet long. Okay. Once you get the picture, the problem is just like what we did last time. The key is to make sure you draw yourself a good picture. When you ask questions about these in class, that's the first thing I'm going to say is, do you have a picture? And if you don't have a picture, I'm going to make you draw one so that you have a triangle to work from. Once you have that, the problem is a lot easier. Okay. Let's tend to one more. We've got a roller coaster. And this roller coaster has the big hill with an angle of depression of 71 degrees. Now the hill is 245 feet tall. I want to know the length of the track. My angle of depression, 71 degrees. Notice again, I'm measuring off a horizontal. Okay. The height of the hill is 245 feet. We're looking for the length of the track. The track runs on the hillside, so the track is this line. Now, to be able to work with this, because this 71 is not in the triangle, I've got a couple of options. I could draw a line over here, just like this one, and move the 245 over here, and I could work with that. That's one option. Or I can figure out this other angle here. Together, this is 90 degrees. So if 71 of it's over here, that leaves 19 degrees to be here. And that's the one I'm going to use. So from our 19 degrees, what do we have? We have the side next to it. That's the adjacent. We're looking for the hypotenuse. Adjacent to hypotenuse is cosine. Okay. Cosine of 19, my calculator tells me, is 0.946. Multiply by the x, and then divide by the decimal, and I get that the track is almost 260 feet long, 259 and change feet long. Had you moved your line over here like this, you would have had sine of 71, which would have been the same value. So it doesn't matter which approach you take. The only thing you cannot do is you cannot put the 71 here. And that's the most common mistake people make. They want to put the 71 here because they think it should be inside the triangle. It doesn't belong there. It belongs against a horizontal line. You can find this angle that's up here by subtracting from 90. So we worked with inverse trig functions, get our feet wet with that, finding angles. And then we worked with angle of depression and angle of elevation. If you had questions along the way, hopefully, as always, you wrote those down. Bring them in with you, and we'll see you in class.